Next note point. If n is odd, then the expansion of x power n plus y power n will be x plus y into x power n minus 1 minus x power n minus 2 into y plus x power n minus 3 into y square minus and so on. Okay, up to the end whenever n is odd. So it is positive y power n minus 1. That is the last term in this factor. So this is the expansion of x power n plus y power n. Clearly you can see, hence, if n is odd, x power n plus y power n is divisible by x plus y. Clearly we can say this. And moreover, if n is positive integer, x power n minus y power n, if n is positive integer, x power n minus y power n, we can write this as x minus y into x power n minus 1 plus x power n minus 2y plus x power n minus 3y square plus and so on plus y power n minus 1. Okay, so clearly we can say that it is divisible by x minus y. It is divisible by x minus y. For example, consider 17 power 51 minus 88 power, let us take place here, 8 power 51. 17 power 51 plus 8 power 51 is divisible by 5. True or false question. Okay, listen carefully. According to this note point, whenever n is odd, x power n plus y power n, in this form it is. So it is clearly divisible by, we can write 17 plus 8. Okay, so it is nothing but 25. Whenever this is divisible by 25, then it is divisible by its factor 5. Divisible by 5 clearly. Yes, it is true. Okay, so similarly, let us take next example. 17 power 30 minus 8 power 30 is divisible by 9. True or false? Clearly you can see, yes, clearly you can see it is divisible by 17 minus 8, nothing but 9, divisible by 9. Clearly you can see, if n is even, you can observe that whenever n is even, so it is divisible by x plus y also. Why? Because, for example, you can consider x square minus y square. Okay, so x minus y into x plus y, like that we can write. Okay, understand? So in the similar way, if you consider x power 4 minus y power 4, x square minus y square whole square. So again, you can apply the formula. So finally, you'll get x plus y into. So is divisible by x plus y also. Listen carefully. If it is odd, only divisible by x minus 1. If it is even here, it is divisible by both x minus y and x plus y. Okay. Odd, odd means only x minus y. Even means both. Okay now. Is divisible by 17 plus 8. That means 25. I think it is very clear for you. Now, in general, we can write x power n plus y power n. X power n plus y power n, x power n minus y power n. Okay? N is even, n is odd. Consider like this. Okay. Listen here. X power n plus y power n whenever n is even. It is divisible by, listen carefully, is it divisible by x plus y or x minus y? Listen carefully, whenever n is even, for example, if you consider x power 10 plus y power 10, is it divisible by x plus y? Is it divisible by x plus y? Let us check. Let us use a reminder theorem. So let us find the remainder when this is dividing this. So x is equal to negative y, we have to substitute to get the remainder. So negative y whole power 10 plus y power 10. So means 2 times y power 10 clearly may not be 0. This is may not be 0. So that's why remainder is not 0 means it is not the factor. So not divisible by x plus y. So is it divisible by x minus y? We have to substitute x equals to what? X equal to y we have to substitute. So x equals to y, if you substitute, again the same situation you'll get, so nothing can be said. Okay. So whenever n is odd, that means x power 11 plus y power 11. Is it divisible by x plus y? Let us check. So x equals to negative y we have to take. So negative y power 11 plus positive y power 11. You'll get 0. So remainder is 0 means it is a factor. Means divisible by, whenever n is odd, divisible by what? X plus y. Is it divisible by x minus y? We have to substitute x equals to y. So 2 times y power 11 you will get. No, not divisible by. Nothing can be said in that situation. So only this can be written. So whenever x power n minus y power n is given, in the situation whenever n is even, x power n minus y, hello, mute your mic. X power n minus y power n whenever n is even. So n, let us take 10. X power 10 minus y power 10. Let us check whether it is divisible by x minus y and x plus y. Let us check. First, to check this x equals to y, we have to substitute. To check this x equals to negative y, we have to substitute. So x equal to y, if you substitute, you'll get clearly 0. X equal to negative y, if you substitute negative y whole power 10, again you'll get 0. So that's why it is divisible by both x minus y and x plus y. Divisible by x minus y and x plus y also. Now, whenever n is odd, here n is odd, that means x power 11 minus y power 11. Let us check it is divisible by x minus y and divisible by x plus y. So, for checking this, x equals to y, I need to substitute. Okay, so if you substitute x equals to y, what you'll get? 0 you'll get. So, clearly divisible by x minus y. Okay, what about this? X equals to negative y, we have to substitute. Negative y power 11, negative y power 11, not 0. So that's why we cannot say it is divisible by what? X plus y. So that's why only we can write these four situations. Understand? Okay, make a note. Next type of questions. Remind when n power m, n and m are natural numbers, is divided by any natural number p. These type of questions we need to solve now. For example, find the remainder when 2 power 157 is divided by 7. To solve such type of problems, first we have to transform the base for this exponential form nearby 7. That means we can write 2 power 157 as 2 power 156 into 2 power 1. We can write this. Powers of 2 nearby 7 is 2 cube. So we can write 2 power 156 as 2 power 3 whole power 52 into 2 power 1. Any doubt? Now 8 power 52 into 2 power 1. So now you divide 8, then find the remainder. A remainder will be 1 power 52 into 2. Any doubt? Now I am dividing 8 with 7. So remainder will be 1. Okay. So 1 into 2. Remainder will be what? 2. Finally remainder in this division will be 2. This is the process. Let me explain once again. So we have to convert the base nearby 7. Then we can solve. I think it is very clear. Next example. 123 whole power 85 is divided by 11. Find the remainder. Find the remainder in this division. So clearly you can see 123 is there nearby 11 multiples. 121 you can see 121 is 11 multiple. So this can be written as remainder. Now I am dividing 123 with 11. Remainder will be 2 power 85. Now you have to divide this with 11. Okay. Okay. Now we have to convert this base to nearby 11 multiple or 11. It is impossible to convert the base nearby 11. So we can convert the base to nearby 11 multiple. 11 multiple 33, 2 power 32. Okay. 2 powers లో మనం 5 పెట్టినప్పుడు 32 వస్తుంది. So that's why 2 power 5 we can take. So 2 power 85 can be written as 2 power 5 whole power 17. Okay. Now it will be 32 power 17. We can write this as 33 minus 1 whole power 17. Now divide this with 11. Now remainder will be negative 1 whole power 17. It will be negative 1. So whenever you are getting negative remainders means which is impossible in the divisions. So that's why take the divisor 11, subtract this negative means you need to add this negative quantity. You need to add this negative quantity. So minus 1 you need to add. So it will be 10. Answer will be 10. Suppose divisor is 12. You are getting remainder as minus 3. Then which is impossible in the divisions. So what is the actual remainder? 12 minus 3, 9. Okay. That's it. So answer will be 10 in the division. Let us prove 2 less than or equal to 1 plus 1 by n whole power n less than n. N is more than or equal to 1. N belongs to natural number. Let us expand using binomial expansion. Now NC1 and NC2, NC3 all were expanded. So clearly it is more than or equals to 2. Let us take this as equation 1. So consider once again 1 plus 1 by n whole power n. So NC0 means 1. NC1 means n into 1 by n. N into 1 by n clearly 1. So expanded NC2, NC3 and so on. Clearly this is 2 plus. Now n I have taken common, n square I have cancelled. So finally I'll get this 1 minus 1 by n into 1 by 2 factorial. Similarly here also. Clearly we can see that 1 by 1 into 2 into 3 less than 1 by 2 square means 1 by 3 factorial less than 1 by 2 square, 1 by 4 factorial less than 1 by 2 cube. So those I have substituted. Before that 1 minus 1 by n into 1 by 2 factorial less than 1 by 2 factorial, 1 minus 1 by n into 1 minus 2 by n into 1 by 3 factorial clearly less than 1 by 3 factorial. So like that I have considered inequality. After that 1 by 3 factorial less than 1 by 2 square, 1 by 4 factorial less than 1 by 2 cube, so that I'll get this inequality. From second term onwards I'll get a GP with first term 1, common ratio 1 by 2. So sum of n terms in GP I have applied. So it is nothing but a into 1 minus r power n by 1 minus r. Substituted, finally I'll get 3 minus 1 divided by 2 power n minus 1. Clearly this is less than 3. Let us take this inequality as 2. So from 1 and 2, this quantity is more than or equals to 2 but less than 3. Hence proved. Let us consider one example problem. Find positive integer just greater than the expansion 1 plus 0.0001 whole power 10,000. Let us solve this. Consider the given binomial expansion 0.1 plus 0.0001 whole power 10,000. Okay, so this can be written as 1 plus 1 divided by 10,000 whole power 10,000. Now you can observe this is in the form of 1 plus 1 by n whole power n. Okay, clearly range of that expansion whenever n is natural number, it is 2 less than or equal to 1 plus 1 by n whole power n less than 3. Okay, so here n is 10,000. So clearly this is less than 3. Okay, so and more than or equals to 1. Sorry, more than or equals to 2. Let us consider this as s. So value of s lies in closed 2 to open 3. So what is the answer? 3.